So this is looking at one of our large-scale medical technology companies in EMEA, actually a global company, and they have multiple business teams that operate independently to one another, and they wanted to think about, well, how do we expose the knowledge, the data that we have within our enterprise, so that the team can, or the teams can extract knowledge in a way that is scalable and pulls together really a fragmented set of different knowledge sources as well. So they wanted to think about, how do we make sure that we manage the cost in the right way. So what we've done here is help them build out a retrieval augmented generation pipeline, or set of pipelines that help scale that knowledge in a way that is cost effective and delivers really quality outcomes for the teams. And lastly, ensuring that obviously the privacy and accuracy is maintained throughout as well. So key objectives for the solution that we built here, which I'm about to show you, is to really enable the teams to rapidly build trusted domain-aware applications. So the architecture that we built looks to align with that principle, doing it in a way that's standardized and scalable. So as new knowledge owners, business teams want to introduce their knowledge into the ecosystem, they can do that in a way that's governed and is scalable. And lastly, more importantly, thinking about reducing that time to value and building the architecture in a way that is repeatable, and we're not starting from scratch every time a new team requests the need to ingest their data. So the reference architecture that we've delivered, I'm about to show you, but part of this is really 3 layers. So thinking about the ingestion of the different data sources, so a multitude of different backend systems, data structures, having that feed into a RAG framework that ingests the and caters for the different data types, creating the embeddings for the vector index to then store that intelligence. We see in the middle there we've incorporated a monitoring and analytics layer as well with Dynatrace. So when the ingestion layer runs, the team can see really clearly, if there are any failures, success patterns, etc. And then from a consumption point of view, so thinking about the end users of the knowledge base that we're supporting the customer building out, is again thinking about the repeatability, building reusable APIs. So if certain business teams wanted to spin up a bot, for example, a chatbot, they're able to do that in a scalable way, providing access to the different repositories through MCP as well. And then downstream, we can think about introducing agents to interrogate that data layer as well. So I'm going to switch over here to show you briefly the solution that we have built here. So I'll switch over to the other org. So 2 components to this. So thinking about that top layer of the architecture, that's the ingestion of that knowledge into a vector store. So we build a process that allows the customer to run that ingestion on a scheduled basis. Data changes over time fundamentally, and we need to allow for that. So what we've got here is a pretty straightforward data source here. We've got a file API, which is exposing some file data across different file types and some metadata as well attached to that. So what the pipeline is doing here is it's calling out to those APIs, it's reading the file content, and then for each of those files, what we're able to do is parse different file types. So I'll just show you a bit around that. So we've got the ability to handle different file formats here. So PDFs, PowerPoints, raw JSON documents, Word files, and CSVs. And we're able to do that in, again, a very structured, repeatable way. So as data changes over time, we're able to reuse and leverage this solution. The next step is once we've parsed that information, so we've extracted the content of those files, we then have a step here to use the LLM to enrich the content of those files. So the customer was particularly interested in, let's think about how do we leverage AI to attach additional metadata that could be valuable for the knowledge store. So we've actually got a call out to large language model here, which is asking it to transcribe some of the text of the content, any images and diagrams, providing metadata around some of the source content, providing a content summary, content keywords. So as well as ingesting and chunking the content of the files, we're actually able to enrich it with further metadata. So once that step has completed, we can then ingest it into the vector store. So we generate the embeddings. The customer uses a RAG service in Azure to vectorize that data. So fundamentally, storing that, and then what the team can then do is plug in any interface. Again, as Paul was talking about earlier, we've actually used Teams here to ask questions of the data. So we've got a field IQ chatbot here. So I'll just take some examples that I've created here that are pertinent to the data that's stored within the vector store. So we can again call out to that retrieval of the data. What's happening here, I'll show you in a second, is again calling out to a SnapLogic pipeline that's going to call out to that vector store based on the user's query, and then provide a structured response back to the user. And this is all sourced from that vector store that I talked about a second ago, and preserving the source link to the data as well. So again, super important for the human to understand where the agent derived its knowledge from, so it can investigate further as well.